Yeah, can you see the screen?
Yes, sir.
Okay, fine. Okay, so today we will start the metal forming theory and practice. So initially we have to, because the module 1 and module 2, I think I thought module 2 we should go first because we should understand what is the metal forming, then from where actually it derived from. Then we should go for the plastic deformation, small mechanism we have. Okay, so today we will talk about the fundamentals of metal working. So we have to understand that how this metal working or metal forming actually this came from somewhere. So we have to go for the manufacturing we have to understand what is the basic background or what how we are calling the manufacturing. Then we have to understand the manufacturing system, then classification of manufacturing process. Then we derive from here the metal forming. Also, we have to understand process planning because the moment we are talking about the manufacturing process, also we have to understand why actually we are going for the manufacturing process. What is basic needs of this process? And then we have to understand the metal forming and then classification of forming process. So today we will cover this much of content. Okay. So in the beginning, I want to just ask because you have already covered the manufacturing process, like the casting and everything you have covered, then also machining also we have covered in the last semester. So can somebody tell what is the basic meaning of manufacturing when we are talking about manufacturing process or we are preparing some product? So how we will define? In your own language you can tell. You do not remember the definition what we have studied in the past. Anyone?
Converting raw materials
Sir.
into useful products using tools and various methods.
Yeah, Charles. Any other?
Sir, like using all of the components to make a final product.
Okay. Any other? Just you can tell. I'm not there is no like exam or something what you know, or maybe what you are thinking, just you can express voluntarily. You have to tell. This is not like every time only just I will talk, you will just listen. Maybe you have to participate from your side. Very few students actually normally participating, so please try to open because you are now in third year. So like you have only I think this semester and one more semester you have, because last semester you have the project. Okay, so you can participate. This is the opportunity you have only. Okay, so maybe in future you will not find this kind of platform. Any other?
Sir, using suitable processes, sir, for converting raw materials.
Converting raw materials.
Yes, sir, converting raw materials into finished goods.
Okay, good. Any other? I put in PPT everything. So just I'm just asking whether you are aware of, we have 76 students, only 3. Any other? No? Okay, fine. Okay. So in the beginning, I just mentioned here in general, manufacturing is the economic term for making goods and services available to satisfy human wants. Okay, so what you all told, this is everything perfect, but also we have to understand the economic term. Okay, because otherwise if we don't, for example, when somebody is opening a company, let's say, or you are after BTech or maybe after MTech, you are going to open one one industry or one company by yourself. So without this term of the economic, so can you prepare a finished product from some raw material? You have to think about the economy, because if you do not have any profit you cannot go. Of course this is part of other side, but also as an engineer also we have to think about the economic term. Okay, all the design, raw material, and their property, their characterization, their finished product, their use, these are all one side, but at the same time also you have to think about the economy, right? And whatever you told, you have some raw materials, you have to go for some finished product, then also you have to satisfy the human wants, or what we are calling every time for proper use. Okay, so we are telling here the satisfy human wants. Then another also, whatever you told, all the 3 students or 4 students you have explained about from raw material to finished product. So also if I will ask one more question, whether this is primary or this is secondary? Anyone?
Which one, sir?
You told this is from raw material to the finished product, right? So if I will ask, is it a primary process or secondary process?
Secondary process, sir.
So why not primary?
Sir, maybe primary would be the procurement of all the materials, sir. Like getting all of them together, that could be primary.
But here also, if secondary also, you have to procure all the raw materials.
It's primary if you're making it from raw materials to some products, and secondary is usually refers to assembly and connecting all.
Yeah, Charles, this is fine. What you are telling, this is exactly we are going to. But for example, any example just you can give. Your definition is perfect, but one example, simple example.
In engine, we can like cast the engine cylinder and piston and all those things separately, and then we have to assemble them together. So making the individual parts is primary manufacturing. Assembling them together and putting everything together and making the final product is secondary manufacturing.
Okay, fine. Okay, so we'll go ahead, then you can tell me maybe in a later stage. So manufacturing involves in a series of related activities and operations such as the product design and development, because normally when we are all are engineers, every time we are thinking about the product design, development, and material selection, then process planning, inventory control, quality assurance, then also this part is important. Because if you see maybe somewhere, if you are when you will go to the campus, or maybe when you are listening from your seniors, that many also the technical students or technical people, they are also going to the marketing, right? Without any management, also without any management degree, they are also going to the marketing. So if you will see or remember maybe somewhere in company also, the technical people, they are working in production, they are working in maintenance, they are working, of course, if you are talking about the electrical people or maybe the electronics people, they are working in electrical side. Then also some technical people, they are going to the marketing side, right? So in view of the above activities and the operation, manufacturing is no longer a simple operation, but has become a system where a number of subsystems interact in a dynamic manner. Okay, so you cannot tell that only this is a simple operation from the raw material or whatever we are buying from the mines or maybe from some company. Then we are just going to some operation or some mechanical process or maybe the metallurgical process. Then we are going to the finished product. Okay, so this is nowadays this is like a combination of some process parameters. Okay, and apart from this also, you cannot tell that only material selection is only one division there, or the product design is one division there. So within that division also you have some subdivision as well. Okay, so if you go to the manufacturing system, what you told, you have the raw materials and you are going to produce some finished product. So I put one schematic diagram here. So if you will see the manufacturing as an input-output system, and this slide or this information already I told in the machining also, because we have to derive from the manufacturing to the forming. In last time what we have done, we derived from manufacturing to machining, right? So here we will derive from manufacturing to forming. So here you can see you have the input. So all the capital, man, materials, machine, technology, energy, information, everything is there. So that means you are putting all the input there. So apart from this also, whenever we are putting some the mechanical process, nowadays also we have some simulation, because all the mechanical students, you are all aware of the simulation system. This is now much more additive to the input also, because you can reduce the experiment numbers, or you can reduce the number of steps or number of process. So you have some objective here. Okay, so this objective is manage the output or the product, what we are calling. So in between you have the technological transformation. So that means whatever the input you have, you are converting to the output with the help of the technological transformation. Okay, in our in material side this is different, in metallurgy we are calling this is different, in mechanical we are calling different, but as a whole we are just telling this is technological transformation from input to get the output or the product. So I just mentioned the everything whatever I explained here in the schematic diagram. I just put here any system that produces useful products or services. In general it is called a production system. Okay, so we can call this whole system is known as the production system, and the production may be considered as a process of transformation. But I told this is only you have to transform from one step to another. So we are not putting whatever the inside everything I told in the previous slide, that you have the product design and everything. And probably if you remember in the NPD, I think who had with me or maybe in other classes. So in that we have divided that from input to output, or the raw material to the product, each step we have designed everything there. Okay, so as a whole just only I put here technological transformation. So for example, the input could be parts and the assembled product serves as output, what Charles, you just told me here. And manufacturing system is depicted as an input-output system. Okay, so if you relate to the computer science also, so they are also using this kind of word that or phrase that they have some input and they have some output, and they are just making this input-output system. And the last I mentioned the technological transformation. Okay, so this middle part, the technological transformation must be optimized. You have to optimize. You cannot tell that only I have some input and I have some output. Okay, so you have to optimize the best parameter with reference to an objective function, which could be cost, productivity, or product. Okay, so you have to optimize because you have to some or you have some objective here, like in the upper part here. So that means you have some goal here. Okay, so based on that goal, so that means it may be cost, it may be the product. Okay, maybe apart from this also you have other parameters. So the manufacturing is the heart of the system where material is converted from one form to another and value is added. So that means you can converting from one form to the another, but wherever you are adding some values there. And the manufacturing subsystem is a collection of process and operations that are used to obtain the desired product in the required quantity. So that now we explained here what is the manufacturing and what is the subsystem. Okay, so apart from this manufacturing also, or the heading also, for example, you are talking only technological transformation. So below the technological transformation, there are subsystem. So based on that subsystem, also we have to go in a streamlined way or in a proper way, right? Is it clear? Yeah.
Yes, sir.
Yes,
Okay.
sir.
So now the present day concept of manufacturing system has evolved through the following distinct stages, because now whenever we are going towards the in the the 20th century, or maybe now we are going to the 30th century. So in that case, what actually now we are considering or we are thinking. So one is a manual manufacturing, whatever we are doing. Maybe 2 days back, I was just looking the YouTube that how the the bucket, the aluminum bucket, or maybe the soft material bucket, how actually they are preparing manually. If you will see, maybe you can just go to the YouTube, you will find very beautifully they are doing, but their safety process they are not following. Because these are old time. And if you will see also, normally we are much more aware of this, because we are just we are thinking of melting of the metals, maybe, or the ferrous metals, or maybe the non-ferrous metals. So in that case we are much more aware of the safety. But as a mechanical engineer also, maybe some people they have visited some industry, maybe in the last internship or somewhere. Probably they have to see what kind of safety precautions they are making. Okay, so next one is mechanization. Okay, for example, if we go to the some developed country, maybe of course in India also now we are making. For example, I visited several automobile companies in Japan actually. So if you will see there in a big hall, like our workshop, in a big hall, you will find a lot of automated equipments, but you will find very less manpower. Maybe for 20 or 30 machines, only one person will be there, because everything is automized. So you do not have any work there. And of course, they have less manpower because their population is less, but they do not need also the manpower, because everything. And if you will see everywhere, some machines, they are they are like some hands are there, and they are moving here and there, but only one person will be there. Very interesting. You will not find, and you will be afraid there like nobody is there. But here, let's say in India, if you will go to the very old university, not like our VIT, very old, IIT, BHU, if you will go, there are some labs or some laboratories. So you cannot stay there maybe in the evening. You will be afraid. I'm not telling that all the students they are afraid, but many students, of course, I was afraid. So when I was doing some experiment, let's say in the evening time, so in the night, let's say at 9 o'clock or 10 o'clock, I have to come and I have to stop the experiment. So actually, I was coming with one or two of my friends. Otherwise, you cannot, you will afraid there. Then third one, we have the hard automation or the automated production facility. And the next we have the soft automation. Okay, so nowadays these are all you are aware of the CNC, DNC, industrial robots, then flexible manufacturing cell. Okay, and the flexible manufacturing system. And what are the major components? You have machine tool, control system. These are already and also
so
last
hard or automation versus mechanization.
Yeah. Which one?
So hard or automation versus mechanization, is it not almost the same thing? Like big
These are almost
robots and
same
everything.
thing. Almost same thing, but only we are talking about hard automation means, for example, mechanization means this is a process. This from this step to this step, you are calling this a mechanization, or the hard automation also in the similar way. Okay.
So PLC comes under which stage?
Which one?
The PLC.
PLC. Maybe
Yes,
I
sir.
am not aware of this one. Maybe I have to check this one.
Okay, sir.
Okay.
So
PLC, maybe it will be soft automation. I do not think this is hard automation. PLC we are talking about for example, when you are in industry, like, for example, one, let's say iron ore is going somewhere, you have to put operate here in some computer, then that one will go there, right?
So yes, sir, it's computer operated, but like it knows like once one hammer is hit it, then it goes to the next hammer. That way the conveyor belt will move, etc.
Yeah. So that's one I remember, because when I was working in a steel company, I operated several times, but not always, because I remember that when we are in a blast furnace, let's say any kind of furnace, if your conveyor belt, if you want to run, then you can put in the computer. I think this is soft automation probably.
Okay, sir.
Okay, maybe I will check once again. Probably this is soft automation, not hard.
Okay, sir.
Okay, I will check. Okay, and otherwise,
What's
please
an
remind.
example of hard automation?
Maybe I have to check again. Okay. Okay, so please remind me in the WhatsApp so that I will clarify.
Okay.
Okay, just that's why, this is not in the part of our this forming, because I just want to derive from the manufacturing. So this is, I think, when you will talk about the CNC, you have, I think, one course CNC and
So CAD
that
CAM?
CAD/CAM probably, because that faculty probably they will tell, because I'm not aware of, I'm not very good in CNC.
Okay, sir. No
So
issues.
maybe that part they will, but still I will clarify that one. Okay, hard
Sure.
automation, soft automation, with one example, just you can put me in WhatsApp. Okay, so that
Okay,
I will next class I will clarify. Okay.
Yes, sir.
Okay. Yeah. So next one, we have the classification of manufacturing process. So these are also we have talked in machining. That's why I asked you in the beginning. One is primary, because in many books they have defined in a different way. So I put here the principal type of manufacturing. One is process type manufacturing, and second one we have the fabrication type manufacturing, and third one we have the assembly type manufacturing. What you already explained me. But here, if in other way, if I have to ask, that's why I asked the question: what are the basic two things? One is primary and secondary. So if we'll talk about the process type manufacturing, so this is known as the primary process. And wherever you have the fabrication type or the assembly type, this is known as the secondary. Okay, so you can just, I put one definition here or one line here so that you will understand. And the process type manufacturing, it involves the continuous flow of materials through a series of process steps to obtain a finished product like chemicals. Okay, for example, also you can take when we are extracting some metals, like say aluminum, okay, with the help of the Bayer's process, or maybe the Hall and Herold process, or maybe any iron also you are producing, like pig iron, or maybe copper you are producing, or maybe the chemicals you are producing. These are from the raw materials you are evolving, or you are getting a finished product, but these are continuous flow of operation. You cannot stop the furnace. You cannot close, and if you will shut down one time, then again it will very difficult to open. Okay, so these are known as the primary process, or we call this is process type manufacturing. Okay, you can remember in this way, process type manufacturing. And the second one, you have the fabrication type manufacturing. It involves the manufacturing of individual parts or components by a series of operations such as rolling, machining, and welding. Okay, so that means we have also the series of operation, but you are preparing some individual parts, what you are you just told in some time before, right? So here when we have the forming process, actually rolling one part from that forming process. So if you follow the basic manufacturing process for known as the casting, or maybe the forming, or the machining, grinding, finishing, these are all it is coming under fabrication type manufacturing, because you are fabricating. For example, if you go to the Vizag Steel, let's say, or maybe any big steel or Steel Authority of India, so they are actually preparing the steel, or maybe the hot rolled product, or maybe the coiled product, or maybe the steel also, or maybe iron they are preparing. But near to the steel plant, you will find many subsidiary plants. Okay, so they are making actually fabrication there. Of course, in the steel company also they are doing, but these people, they are making the major part of primary manufacturing, or the process type manufacturing, right? So here also in the last time we talked about the machining actually. So the machining also a fabrication type manufacturing. In the similar way also forming, whatever we talk or we are telling here, or we are talking here, the forming of rolling, then forging, then extrusion, or maybe the wire drawing. These are all coming under the fabrication type manufacturing, right? And the third part, we have the assembly type manufacturing. In this type of manufacturing, the part or the components are put together to get a complete product such as a machine. For example, nowadays you can see some car company, let's say we do not have any manufacturing setup here. So what we are doing, So we are taking all the parts from outside, maybe from German or maybe from Sweden we are taking, but we are making assembly here. Okay, and the moment we are making assembly, then we are selling from here, right? So these are the basic three manufacturing types are there. So one is process type, fabrication, and the assembly. Fine, is it clear? Yeah.
Yes.
Sir,
Yes.
is the assembly type governed by PLC and SCADA, or do we have manpower still?
You need manpower. This is like a assembly, like, you have different parts are there. For example, like, you have, let's say, one engine is there, then one like, other parts is there. You are making assembly, then you are making a, let's say, motorbike or maybe car. Okay, you are not preparing anything, you are not manufacturing anything. Okay, right? Yeah.
Yes, sir.
So in the second, I also classified in a different way. The manufacturing process are also classified in the constant mass process and the like, the metal removing process. And then also you have the material addition process. Okay, so probably I do not know whether you have aware of all the things. I think the metal removing, I think you have already done in the previous semester, and the material addition probably also the welding part also you have done in the previous semester, I think. Okay, because I had these two courses we were running in the previous semester. And the casting also, I do not know the manufacturing process is there. I do not know whether this was in third or fourth semester somewhere. I'm not aware of this. Probably you have studied, I think. Only
So?
the, yeah.
So which are the courses for metal removing and metal adding? I don't think we have done both of them.
No, you have done. Metal removing is like, last time you have done the machining, turning, drilling, milling, these are you have done.
Okay, sir. So manufacturing processes.
No, this is not manufacturing process. This
Machining.
is
So
machining and metrology you have done.
okay, so got it. Yeah,
And the
yes.
material addition, this is welding. The gas welding, then the brazing, soldering, thermite welding. Many weldings are there. All the
Okay, so
riveting.
that
These
is
are you have.
pending. That is pending. Yes, sir.
No, that is finished. I think welding. I think last semester. I think one faculty.
So
I know.
they gave it as elective, so that's why only half of the
Fine.
people have
Okay,
taken.
so maybe we'll have the option probably in the next semester, I think. Okay, so we will. I'm not going just only. I have classified. So that's because many names actually as a mechanical actually, because this is in metallurgy. These are the core subject. Okay, so we know which like title is good and where we can put. But in mechanical, everywhere this is like a mixed one, like machining, then like manufacturing. In manufacturing, they put everything. Okay, but we have to define actually. Okay, you cannot tell that everything comes under manufacturing. Of course, everything will come, but again, you have to subdivide. That's why I told the subsystem is important. Otherwise, you cannot tell that where actually from how it come. Otherwise, I can go from metal forming immediately. Okay, so what is metal forming? Then what are the classification or what are the types? Okay, but we have to know the basic background from where actually it derived. In machining also last time I think Charles probably, if you remember, we have done in the similar way, because otherwise how we will know, how the students they will know, right? So if we'll talk about the constant mass process, so I'm not going to in detail that how the process actually they are making or how they are making. Just I put what are the process actually. So for example, the casting, then you have done sand casting, sand mold casting, many things you have done. Then actually this is much more important. We have the metal forming. So this is also falls under the constant mass process. And in the same way, you have to also step by step, because all the module, I think we have third module, I think probably forging, then fourth is rolling. In the previous class or in the first class, I have told about the syllabus. And then we have the wire drawing. So today just I will put the forming classification, 1 to photos just only I will show. Then step by step we will go for the like an application side. We have to derive some equations, and then we have to go for the application side. Okay, so here we have the rolling or maybe drop forging, press forging. So I do not know whether we can cover everything, but we have to touch something like rolling, forging, extrusion, wire drawing, deep drawing, everything will make it clear. Then at the same time also powder metallurgy, also one process is there. Heat treatment is there. Probably heat treatment you have covered, I think, material science and technology in the beginning of the semester, I think first semester or second semester, material science and technology. And the powder metallurgy, I think in unconventional, probably I will teach you in the module 6 probably. Okay, a little bit of powder metallurgy. Then at the same time also the powder metallurgy I have covered in where the composite materials, right? I have covered that many powder metallurgy process, solid state, liquid state, gaseous state. Okay, so if you do not know, because we do not have, I think, this syllabus, otherwise we cannot finish. So if somebody wants personally to study, then maybe I can help. Okay, And the metal removing process you have already covered, the machining, turning, drilling, everything I have written here. Okay, the unconventional machining also we have covered, and the material addition, the welding also some students I think they have covered in the last semester, and who has not covered probably can go for the next semester. I think they can put in elective. Okay, I do not know who will teach. Maybe if they will offer me, probably I can also teach, or maybe other faculty. Okay, we will meet in the next semester if I have this option. Fine, is it clear? Yeah.
Yes, sir.
Okay.
Yes,
Okay. Yeah. So next one we have the selection of manufacturing process. So that means whenever you are talking about any manufacturing process, I think the same question also some students they ask me in composite materials. I remember. Okay. So whenever you have some process or some many processes are there. Whatever I told in the previous slide, many processes are there. But how you will select which is the best process for me? Okay, so you have to understand or you have to think about. For example, now I will just ask in other way. You choose BTech mechanical. So how you will choose? In what parameter you have choose that one? Anybody? Just tell me maybe 1, 2, 3 points. What is the basic parameter when you are choosing one BTech mechanical or maybe MTech mechanical? You will go maybe CAD CAM. Somebody is interested in CAD CAM. Somebody interested in manufacturing. So what the parameters are you are looking for? Anyone? Just guess or tell, because there is no guess here. You have to tell because you have already chosen your career. Now you are in third year, end of the third year. Anyone? No, because this is your chance. This is, you have to tell me. No, there is no M. Sai.
So I was
Yeah,
interested in
Nihar.
heat
Yeah,
transfer.
Nihar.
I was interested in heat transfer and all the thermal related things. So mechanical is the only branch that offers the course.
No, that is your choice. But why you choose that one? For example, I'm asking BTech mechanical because you are not chosen BTech heat transfer or heat and mass transfer. You have chosen BTech mechanical. Then you have to go. Let's say if you are going for MS or maybe MTech, you have to choose specialization. Let's say heat and mass transfer. MTech mechanical in bracket heat and mass transfer. But why you are choosing this one? Or why you have choose BTech mechanical? Maybe any two, one or two you can just tell them. This is not hard and fast rule that you have to tell.
So
I'm asking you have to tell.
I was more inclined towards having industry exposure, which I would only get in mechanical engineering than other computer science courses. So the industry exposure that I needed is offered by mechanical engineering.
Okay, this is good, but still you have to do not think that in world only we have mechanical. We have chemical, we have ceramic, we have metallurgy, we have materials, we have textile. Okay, we have design. Many are there. So you will all get in. You have electrical, you have electronics. Computer you are not, but still computer nowadays everywhere now we open a BTech mechanical with specialization computer science. So industry experience you will get from all the all the specialization. Computer also, do you think that you cannot get? You will get, for example, if you go to a steel plant. So that's why maybe somebody was asking about the PLC because I was working in PLC. Maybe a few because I was shift in charge. But sometimes we have to, if for example the normally the diploma students they were working in PLC. Okay, because they have to sit there, they have to proper calculate how much material actually we have to put. We have to make the balance sheet, or maybe how much raw material we will put there, so that how much of liquid iron will, or maybe liquid metal will come out. We have to calculate. We have to instruct the PLC people that you have to add now this much of coke, you have to add this much of iron ore now. If the, let's say, liquid metal is composition is little different, so you have to tell whether the liquid metal is, let's say, now little cold. Okay, so cold in the sense this is not like 0 degree or maybe 20 degree. Cold means there is some carbon composition is less there. Okay, so in that technical aspect we have to tell, you have to charge now coke so that the metal will be hot, right? So that means the carbon content will be more. So similarly, so I'm asking why anybody, for example, you are buying a motorbike. Now, for example, maybe many different companies or branded motorbike is coming. Many people they are thinking about Pulsar. This much of power engine I will buy. So why? Or maybe
Sir,
yeah, Anil, yeah.
Sir, is while buying motorcycle, you would look at various parameters, sir, like engine performance, chassis, the dimensions, the tires, the suspensions and all.
Yeah.
So
Good.
which
So,
suits you more, which is more optimal for you, you would choose that motor bias.
yeah. This is the perfect answer I was asking. Maybe, yeah, I
Sir?
think Avito, I think he wants to tell. And that's why I'm telling the moment you are buying, yeah, Avito, 1 second. So that's why
Okay.
I'm just clarifying. So if you are buying a motorcycle and you are checking these much of parameters you have, but the moment I'm asking, you choose the BTech mechanical, what you looked at that time, the parameters. Yeah, Avito, go ahead.
So when it comes to the bike, also efficiency, aesthetics, and brand.
Yeah, this is fine. This is fine. Now,
So
bike I understood
we
now.
can apply
So,
the same brand type of thing to VIT
yeah.
also.
Yeah, great. So now all the students, that's why I gave the one more example. You talk about bike. Maybe after 2 years, when you will work, I think somewhere, then at that time, I will not ask you bike. I will ask you about the car. Because these are
Yes.
the generation we are going. So now I just the initial stage. Now again, I'm going back. Why you choose BTech mechanical or why you want to go for MTech heat and mass transfer or MTech manufacturing or MTech CAD CAM? Any two education just only you can tell. One example, then we will go to the mind content.
So because mechanical is the core topic, so that means you are at the root of the branch. Then you can go into anything compared to into going into something else first itself.
But if you have the chemical, you cannot go. If you have the chemical or if you have the ceramic or if you have the polymeric engineering or if you have the computer, so you cannot go to the core branches or the whatever you are telling.
So you can, but it's slightly of a more complicated process.
No, but you can just talk to a computer science friend. You can just talk to a computer science friend what he is telling, because for example, if I will ask a computer science student, he will tell computer science the best, this is the royal branch. And if I will ask a ceramic person, he will tell the ceramic is the best branch because you can publish a lot of papers, you can get a good job. The industry experience everywhere you will get. Internship you have. So that doesn't mean that computer science people they are not going for internship. They are going for internship.
Excuse me, sir.
Yeah, Anil. Yeah.
Sir, the main parameter that I looked into was the ease of branching into or specializing into any field, sir. Like I believe mechanical engineering is a generic course where we have heat transfers, designing courses, manufacturing courses. So when we get a really good idea, in future we can branch into it. That was the main parameter I looked into.
Yeah, this is a good parameter. What Anirudh said that this is a good parameter, but you should have some specific goal. Okay, you know everything. For example, I know heat transfer, I know manufacturing, I know casting, I know CNC, I know, for example, any other mathematics, physics, chemistry. I know everything. But what is, for example, the bike? Just only you have money, you are buying that one. No, you have some certain purpose, right? For example, the manufacturing process when we are talking about, I told this one you are converting from raw material to final product. You are spending money, you are checking also for your economic purpose. You are not telling that, or you are not doing only for the society. Of course, our generalized term, we are doing everything for the society, but that doesn't mean that you are not getting or you are not gaining anything. But you should have, so what I told in the one phrase, that is the benefit for the human, for or example, the for certain use. Okay, so that means when you are doing your BTech mechanical, finally maybe you have the option that I will get a good job, or maybe nowadays many students they are talking about the package system. Okay, so maybe I will get 24 lakh package, or maybe I will get 25 lakh package. And for example, if we'll go to the, let's say nowadays, many people they are also working with BTech mechanical or maybe any BTech with management. So do you think that the moment they have done the management or the MBA they have done, do you think that these people they will go and they will do in the production sector or maybe in the manufacturing? They will go to the marketing side. Of course, they can work in a production company, but they will go to the marketing side. They will not work on they will put this much of raw material and they will cast some billets or something. They will not do. So nowadays, that's why I told this is a multicultural system. Everything, for example, the mechanical people they are going in the software. Also, you people also will go. I know. So how we will do in the software your heat and mass transfer when you will do the software development? Is it workable?
Not exactly with coding, but with ANSYS and all we can.
Yeah, but for example, when the ANSYS is, let's say you are doing one part here. Okay, for example, ANSYS or maybe the CAD CAM, whatever you have, you are doing one part, but they will not give you 1 lakh salary for this ANSYS of one part. Okay, because you are after graduation, you will be a gazetted one, like you have the graduation. So you cannot tell that only this part. So if this part they will do, let's say in a production company, they have other like persons are there. For example, diploma people are there, ITI people are there, or the BA, BSc, the supervisor, they are there. So what is then how we will distinguish how the salary distribution will be there? Right, so we have to think that one. Maybe now, maybe this is too early maybe for you, but I do not think this is too early, because you are going to end your third semester, so you have only I think including this semester you have only 1 year. So you have to think, because probably in the campus placement, many people nowadays that I remember one time we interviewed in one university, earlier university. So one PhD candidate came. So and a good experience, maybe 8 or 9 years experience. So our vice chancellor, he was asking what you can give for the department. Then the candidate told that if you will give the facility, then I can do. Then he told this facility if I will give, then everybody can do. So why I will pick you? So the vice chancellor asked the the specific question that I will not give you anything, but what you can give to the department. Okay, so then in that, because if you cannot answer that one in the proper way, you can tell that I can give any answer, but that should convince to the person who is recruiting you. You cannot tell that I will just tell, no, sir, I cannot do anything. So if you will give only, then he will reject. He will tell reject. Okay, so you have to tell in such a way, you have to tell in a diplomatic or in a polite way, but it should satisfy to that person who is recruiting you. You cannot tell that I cannot do, because now you can tell to the faculty, because you are our student. So whatever you will tell, we have to listen. There is no other choice for us. And you can tell, because, for example, maybe some days back, one student might be earlier student. He asked me, sir, you have given in this assignment a 0. I do not know whether the student is here or not. Then I told, I do not remember actually, because long time back I have given. So please check actually, maybe by mistake also from my side, probably it is possible. Then I told, okay, please call me. Then he said his registration number, everything. Then I checked. So I told, have you copied from somebody? Then he told, no, sir, I have not copied, and I submitted on time. So when I checked, so this registration number was from different student. So he also, he's a mechanical engineer. So he could not give or find some time to change the upper template also. The other student registration number were there, and other student name was there. So then when I told, have you copied from this student? He told, no, sir, I was just taking the reference from him. Then I told his name was there. Then he told, okay, sir, I'm sorry, sir. Then I told, do you expect more mark? No, sir, this is fine, thank you. So what I will do? Charles, what should I do?
Not give him the marks.
Yeah, so this, I'm not telling that we should mark is in a different, but your your work style. That's why I'm asking maybe Anirudh to give a good answer that this is my focus. But also you should have some specific goal. Maybe the normal answer is we should get a good salary, good position. Maybe proper freedom should be there. In that company, whatever, because you are a design people, you are an engineer, so you have to think whatever in your mind, you have to use there. You can tell that, sir, whatever my experience is there, of course I have less experience now, because only theoretically I am expert, but practically I'm not. Maybe I can use my theoretical experience or theoretical knowledge, and I can implement there. Maybe you cannot implement. I know this is theory and experience or practical, both are totally different. But at least in that similar time, you can tell this kind of answer. Maybe apart from this also you can find. Okay, lot of, but you have to tell that what is your goal. You should not tell that I will work for the society, I will work for the university, maybe I will your aim also you have to tell. Maybe I need different location also, that is also one answer. But you cannot tell only that. And for bike you told many things. I need this engine parameter, I need this parameter, that parameter. But for education, why not? You have to tell, right? Is it clear?
Yes, sir.
Okay.
So, but
you have to
later, do they check if you
understand.
actually complete your goals that you mentioned while recruiting, or it is only a one-time say type of thing?
Yeah, I think this is one type of say, because you can, maybe some people they are doing, but in India actually the problem is you cannot get all the facilities. Our hierarchy is different. But if you go to the abroad, then you can do it. You can do it. Definitely you can do. Whatever you want, you just because, but you have to go for the developed country, not the
Yes,
developing
sir.
country.
Yes,
Yeah,
sir.
so this is my experience, just I'm saying. In India, we have a lot of hierarchies there. So you cannot, if you are doing something, maybe some other people, they will not let you do. Okay, so maybe, but do not think about the negative side. You can think about the positive side. Okay, yeah. So now also when we are selecting some manufacturing process, so also the same answer just only I put here, you have to think about the cost. So you have to think about the least cost I just highlighted, then also the reasonable time you have to think, then also the quality. Okay, so sometimes also we need quantity, but majorly you have to think about the quality of the product. If you have the quality of the product, then your customer numbers will increase. Okay, you cannot think about the quantity at that time. Of course you have to think about quantity, because if you have only maybe I will tell you one more example. One time when I was abroad, actually I was collaborating with a Belgian professor. So you know, he was very choosy, and I told we can publish some papers, because I had some data. So I told we can publish some papers. Then he told me what kind of test you have to do here. Then I told this thing. Then he told, no, this is already old. Old means these are already, you know, many people they are doing. So what the uniqueness you will do so that nobody has done in the world. So he declined. Okay, so that's why I'm telling you have to think about the quality of the product. If you will not think about the quality, only quantity, so maybe you will be only within this limit of the zonal area. You cannot go to the outside side. And the final product should satisfy both functional and the physical objectives at a minimum cost that is acceptable to the ultimate user. Okay, so sometimes what we are calling, let's say you have some car, or maybe the like, you know, the some, like, you know, if you will see the Activa is much more popular. But if you'll go to these other, like, you know, that kind of model, I forgot this name, maybe some Suzuki something. So that one is not acceptable. Maybe for some years it was working, but after that it was not acceptable to the customer, right? So for this purpose, production and the process product topology technique is used. Okay, so that means you have to think about the everything, the cost, the time, and the quality, the manpower, the, like, you know, the convincing or the acceptability. Okay, so these are you have to think. So all the selecting of the manufacturing process. So these are also the what are the parameters, or the what are the points you have to consider: the manufacturing cost, production volume. You know, these are already, you know. So just you can read when you have the free time, or the limitation of shape and size, surface finish. These are already you have covered in other manufacturing processes. Okay, then also when you are talking about the process planning, so the process planning also you have to plan accordingly. For example, that's why I asked the similar question when you have let's say, you know, when college reopen. Okay, so you have planned, many questions are coming from the property. Okay, how to plan, how to design that one, what we are planning. For example, you are going for vacation, you are planning from the long time back. Okay, but if I will ask, maybe I do not know, we are not looking, maybe physically when we'll meet, maybe I can ask the same thing. Whenever you are planning for the exam, okay, you are not planning, because you are telling this is open book exam, so everything is there. And some people, maybe I do not know, you will laugh like, you know, when we are checking the students, you know, they have several devices. Maybe some people, I do not know from our batch also, some people they are doing or not. They have several, because we are checking other students also. They have several devices. They put on the, like, you know, under table, they are putting one device. And every time, because when we are looking, so their eye is not to the laptop or not to the paper. Their eye is every time moving from paper to, like, you know, under table, then under table to paper. Their eye is moving. So they have several devices. That doesn't mean that we do not know. Okay, but the option is like this, so we cannot do anything also, right? So also at the same time, you have to think about the efficient and the economic planning. Okay, so these are the parameters also you have to think. The other process planning parameters also I put here, like, you know, everything, many points I just put. You can just have a look to this one. Okay, maybe you can, I put many things which relate to mechanical. So you can just read when you have the free time. Okay. Then we have to go to the metal forming. So what is actually metal forming? So the metal forming process, are known as the mechanical working process, are the primary shaping process, in which, do not misuse this word again. The primary, I told from the raw material, the continuous process, but this is known as the primary shaping process. Okay, this is not the primary and secondary what I told in the beginning. This is the primary shaping process, in which a mass of metal, okay, or the alloy is subjected to mechanical forces. That means you have to give some mechanical forces so that you can apply or you can produce some different products. Under the action of such forces, and the shape and size of metal piece undergo a change. Okay, so also at the same time, also you have to think about the economy, and also you have to think about the time. right? And here actually two kind of deformation we have. So one is elastic deformation and one is plastic deformation. We are now going towards a little bit of mechanism side. So one is elastic deformation and second one we have the plastic deformation. But where in metal forming, actually it is undergoes with plastic deformation whenever you are making a processing. Okay, and also we have the temperature when we will study about the how the temperature affects something. So also we will talk about the hot forming or the hot rolling, maybe cold rolling, or maybe the hot forming, cold forming. Also we will talk. Okay, now just only definition on the information just I am giving. Okay, so in plastic deformation, actually we are talking about the permanent change. Okay, whenever you are giving some mechanical force, you are getting some permanent change here. Okay, so I put the definition here. When a single crystal is subjected to an external force, it first undergoes elastic deformation. I think these are already you have studied in strength of material, and that is it returns to its original shape when the force is removed. Okay, like the elastic nature. Okay, so that means whenever you are applying some force, it is changing, but the moment you are removing the force, again it is coming back to the original position. And also the plastic deformation, what I told, you have to go for the permanent deformation. Okay, this is plastic deformation, or in other word, or maybe in otherwise we are calling this is permanent deformation. So in other word, also the forming, what I told in the previous slide, the forming is a fabrication process for solid substance by controlling plastic deformation, because that's I told every time you have to control the parameter. Okay, you have to optimize that one. So the solid substance by controlled plastic deformation in order to obtain the proper form, whatever the required form or whatever the customer demand, you have to prepare the proper form. Then the material property you have to calculate or you have to check. Then the surface property. Okay, all the parameters, maybe apart from three also you can find a lot of things are there, but these are the basic three property you have to get. One is form, because many people they are working, they are finding like wire, let's say they want, or maybe some they want thin plates, or maybe some people they want billets. Okay, so in that kind you have to find or you have to prepare with proper form, and the material property is important, then also the surface property is important, right? So if forming you have understood clearly, is it clear in the forming process? Maybe I will take another 3-4 minutes. Okay, so there are actually some terms. So whenever you are classifying, so type of the raw material you are classifying, then also the classification you can classify by the state of stress and the forming temperature and the methods of induction of forces into the workpiece. So depending upon, you can also classify accordingly. So that's why I told in the beginning, many books they have different kind of classification, maybe primary, secondary, then maybe like what we discussed here also. In the similar we have to go, but I put in a different way that you have to classify accordingly from the manufacturing to the forming or maybe to the machining. Then you have to, according to the raw material you have to classify, according to stress you have to classify, temperature you have to classify, and then the forces, the moment you are applying some forces, based on this also you can classify. So if you will see the forming process, so I just mentioned again here, this is a plastic deformation, and the external load you have, typically this is compressive, and sometimes you have the stress the metal, and what we are calling this is tensile, and the bend the metal, and this is known as the tensile and the compressive, and sometimes we have the shear stress. Okay, so the force per area. Okay, and here actually we are doing the die and tools. Normally we are using this kind of equipments or this kind of parts we are using with the help of the die and tools. We have to prepare the metal forming or the plastic deformation we have to take. And the classification we have defined or we have classified in two ways. One is bulk deformation, and second one we have the sheet metal forming. And the metal forming again I put in a schematic way. So bulk deformation again we have rolling, forging, extrusion and wear or bar drawing, and the metal sheet metal working is bending, shearing and dip and cuff drawing. Okay, so these are the, maybe apart from this also you will find some like stamping kind of things you will find, but these are the main classification we have of the metal forming. Okay, so I have only 1-2 photos how to find the bulk deformation, and characterized by the significant deformation and the massive shape change. Okay, so this is known as the rolling, the first picture here. Okay, so that means you have two rolls, and the rolls are rotating in the opposite side, and here you have the solid piece in the left hand side. We will go in detail in rolling, all the with mechanism and the numericals. Okay, just only I am giving you the basic information. Here you have the solid metal, and the moment you are rolling, you will find a different shape. Okay, and all the force you are giving from the top and the bottom, because you are this is like rotating, right? And similarly we have the forging. So you have the die here, and this is the workpiece here, and you are applying from the force from here. So that means you are pressing. These are we are calling this is forging. And the third one we have the extrusion. So in extrusion what happened? In extrusion you have the die here, and you have the ram here. So you have the metal here or the workpiece here. So the moment you are giving force from the back side, and you will find from here with a different set. Similarly you have the drawing. Okay, so your you can see here workpiece is like this and die is like this. So you are just drawing. Okay, so that means you are applying the force from here. Okay, so you are stretching, or maybe you are pulling something. Okay, so these are known as the bulk deformation, and we have a separate module for this. So we will go one by one. And the next one, we have the sheet metalworking. So forming and related operation performed on metal sheets and strips, and the high surface area to volume ratio also you have to think here. And here also I put some example of the bending. You can see here. This is the die and this is the workpiece here. And the moment you have the punch here, and if you will press, then you can bend it. For example, if you go to the any the iron work shop, or maybe the grills, for example, they are working. So here you can find the bending. Similarly, you have the drawing. So maybe that's one I saw actually 3-4 days before that, the aluminum bucket, how actually they are preparing, the handle, actually the top portion handle. So I saw it looks very beautiful. So you can see here, this is die, and you have the force you can apply from here, and this is small thin sheet. So if you want to make it this kind of structure, or we are calling this drawing, or we are, in technical term, this is known as the drawing. Similarly, this we have another one. This is, yeah.
So why is drawing different compared to bending? It looks the same.
No, bending is you have to make it, for example, 45 degree, or maybe 90 degree something, the rectangle shape, for example.
Sharper angles, sharp corner edge, like almost.
Yeah. So this is bending, and drawing means you have to make it a curve. Okay, so another also was there, but I forgot that one. Maybe that is maybe we'll study when we will talk about the deep drawing. And deep drawing, many different kind of subsystems are also there. Just only I want to show here one photo only. Okay.
So what is supporting the other end of the shearing part? I mean, the representation is wrong in the shearing.
Shearing? Why?
So because when you apply the force from that side, what is supporting the other part, the unsuspended part?
This is a cantilever. No? This is only cutting. This is shearing means this is you are cutting. For example, this is a cantilever side. Okay, so that means if you want to press here, so that means you are cutting from here. Okay, so there is no support here. It will fall down. So that means you are cutting two pieces.
Okay, so is that a cutting tool?
Yeah. This is like this is not a tool. This is a punch only. Cutting means is different, but this is similar to cutting. You are not bending anything. Okay, that means you are getting two pieces here. You can see here. There is no link between the second piece and the first piece. You are cutting. You are separating from that. So this is known as the shearing. And this is similar like cutting, but this is not a cutting tool. This is a punch actually. Cutting tool is a different what we have studied in machining. Okay, but you are separating from one piece to another. Okay.
Okay, sir.
Okay, if any other question, you can just ask. So today we'll stop here because already you are late. You have another class, I think.
Yeah, so there's a question with the shearing itself, like the unsuspended part. What is it supported by? Because when you have the punch pressing it hard, it would topple, right? The entire thing would topple on one side.
This is a cantilever. Cantilever is one side is supported with the die, other side is not supported. So you have to cut. If you have support, then how will cut it? How will fall down? And this punch, it will not fall. There is some, because this is schematic diagram only. Okay, but this part will fall down here because there is a if you see somewhere in company, maybe I will show you some rolling mill. Maybe if I have some videos, I will show you some rolling mill, how the roll product is coming continuously, very long product, but somewhere they are just, they put the punch here. So it will cut several pieces. The long product, they cannot take from somewhere. They, for example,
So it could be said that this can be used when they are using some sort of extrusion process. They can chop out to make the size needed.
Yeah. That's what I'm telling. So if you have a big long product, because this is a continuous process, this is not a small piece is coming. Very long sheets are coming. But they want to, for example, customer is needed, let's say only 1 meter piece. So they have to go for the shearing. So they can, it is coming and suddenly it is pressing. So it is going to other side.
Do we need post-processing after this? Post-processing? Because
you have to. Yeah, you have to, because this is a hot product. You have to go for the cooling again. Because red color product is coming.
Oh, okay, sir. So this is not done when it is cold.
No, we have to go for the cooling. You have to, because it will go to the again for cooling chamber. Then again they have to go for, if the customer they wants the raw product from there only, they can take. But if, for example, you have to go for the finishing, let's say, like, yesterday I was looking, some thin plates were going in the truck actually. So they have to go for the coating, let's say they have to go with to avoid the corrosion. Otherwise, they have to go for the polishing also. Okay, many processes are there. This is just only one, one process we are talking. That's why, manufacturing unit, if you will go, there is not only the shearing is there, only drawing is there, only bending is there. Lot of, if you go to the ceramic also, you can go. Many different stages are there. You cannot tell that this is the final product, and maybe some people they are taking because of low cost, because that one is not polished. So maybe with low cost they can buy. For example, if you go to the the machining company, the chips actually we are getting the waste chip. We are buying from there also, because we have to go for the again remelting. Again we can sell that one. Okay, or we call this is recycling, right?
Yes, I understand.
Yes, sir.
Yeah, many processes are there. So if you will, maybe I do not know whether we have some option, because this is online again. Otherwise, you can visit any any industry so that you can see. Because I remember many because I was working in a steel company. So, and also in Turkey we visited many rolling mill. But here only I think SEL, probably Steel Authority Rourkela I have visited once. Then otherwise. Here in Chennai, I have not visited. Maybe if, for example, in future we will have offline classes, maybe we can visit one rolling mill. Okay.
Yes,
Okay,
sir.
sir.
Yeah. Okay. So if any question, you can. Otherwise, we can stop, because your next class will start soon, I think. Yeah.
Thank you, sir.
So,
Okay.
so can
Yeah.
all of these be done cold also? Because mostly you say sheet metal is they do cold bending.
No, for example, if you go to the some people, they are sitting in the street. They are shape of the iron piece, let's say. Okay, so what they are doing, so they are putting in the fire. Okay, so the moment it will become soft, then they can hammer it, so it will change, or it will change the shape. Okay, for example, I do not know here in the street actually in Chennai, where I am living near to VIT, I have not seen. But if you go to the city side, you will find maybe, or maybe in the local village somewhere, they are changing the shape. We are calling this 4G. Okay, but if you go to the company, actually company, they do not have any small shop. So they have actually big rolling seats are coming. So they have different, what I told, the shearing actually. So this one you have to cut somewhere, so that, because where you will take that big seat. Or for
So,
example, in steel melting shop, I am telling another example. So you have the liquid metal. So the liquid metal, where you will take, to whom you will give. So that one, what we will do, we have to put somewhere in the continuous rolling there. So there are some mold are there. So in the mold we will pour it, and after solidified, then it will like a hard piece, and the small pieces you can sell. So in a different company at different stage, they have different system. Okay, but the technique is same, or the aim is same, or the goal is same.
okay, sir. Okay.
Okay. Okay, so I think when you will see some company, you have a lot of questions will come, because the initial level. Okay, but the step, maybe we will see some videos. Maybe I will try to find out some video when we will study rolling forging. One video I will show you, so that you will get it clear. Okay.
Okay, sir. Okay.
Okay then.
Yes.
Okay, so thank you very much, and have a nice day.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.